Everybody say like, share, subscribe. Niche video is coming soon. Say.
No promotion.
Like, share, subscribe. कर लो यार, एक.
So, hey everyone who is listening to Vishwas podcast, great that you guys are here. And my name is Nish. I work on the .NET team, specifically the community team. I speak about .NET. I help developers build production-ready apps with .NET. So .NET/architecture, if you go there, there's some great free ebooks to get started. There are some great guidances to get you hands-on tutorials to get you started. So all those things that you see there, that's what I PM on. So I work as a program manager. So my job is to work with customers, work with my product team, make sure that we build some great products, make sure that we are solving customer problems. So this is what I do. So yeah, I'm on Twitter, Nish Anil. So feel free to follow me there later.
I welcome Nish sir for this podcast. This is a kind of a podcast where I'm not just doing with that developer advocate who just came back to the program management stuff and just leave that, just leave the fact that he has had so many transition in his career. But, in one of his, not an interview or a podcast, I don't know that, but he's told that, it was just something that we started and it didn't work out. So we just threw it away from the mindset that, okay, it was a failure. Now we had to evolve over a course of time. And then he started building himself as an amazing engineer. Trust me, see his sessions. You feel like he's an amazing engineer, by the way. And all his session, of course, his career was completely filled with .NET. And moreover, when you think of his career, okay, it's all about .NET. But of course, there are a lot of other technologies that he has worked upon. And let's just demystify a lot, because I think a .NET developer can give an amazing perspective about the tech that we are supposed to be working. And thank you so much, Nish sir, for giving time and also accepting this podcast, even in your busy schedule.
Oh, really? It's a fun time to be with you. I mean, when you started the intro, I was just thinking, whom are you actually talking about? Because you spoke so many nice things. And I was wondering, who is that person you were actually talking about? So you technically went through all my profile. Where did you search all these things? Is that on LinkedIn?
Not on LinkedIn, it's on YouTube and other places that I just went through, right? So before the podcast, I make sure that I research a lot about my speakers, because I need to collect as many good insights as I can. So that's what it's all about.
Nice. So and thank you for having me, Vishwas. I went through some of your older ones and it looks really, really interesting. And I really appreciate that the younger generations like you are more inquisitive about how we have gone through our journey and things like that. So which is a great thing. And I hope whatever we discussed today is useful to your listeners.
Yeah, let's just start your journey as a student, because you went down, start a company, and you just told that, okay, degree is something good, but we just want to do something else. And even in the college, you became an entrepreneur and you started becoming a co-founder and the CEO of a company. So
how was the journey? I really want to know, because this is not a public info. And
no,
only very close friends
of mine. LinkedIn. It's there in your LinkedIn, and also in one of your friends' interview, you have explicitly talked about it. We started something in the college, and it was like, okay, it didn't work out well, and we just threw it off, and we just went to the cave.
Okay, interesting. Yeah. So yeah, I didn't know LinkedIn still had that thing. I haven't looked at it in a long time. That is true. I mean, when we started, I think so in between my college, I think it was in the second year or almost the third year, maybe. During those times, when you have like-minded people, when you're chatting with them, you kind of throw in some ideas. And then so this I'm talking to you about sometime in 2005. 2005 or 2006, early 2006 or the late 2005, right? So we were thinking, okay, we need to everybody gets a project to do in the college and things like that. So we wanted to do something really, really nicer. So we started writing, as always. I mean, you would have heard from many stories from the colleges that you start writing softwares for your own college. And that's how we started writing some softwares for maintaining college records. And then we realized attendance became a big challenge, taking the attendance. And then the college wanted to submit a report to the parents and things like that, right? And so we thought like, okay, let's build this thing. And one of my seniors at that time, he was very good with his electronics and things like that. So at that time, he actually built a small device which actually put all the records of all the student data of entire college in a single piece of device. And then we used to sync that devices, yeah, using a USB connection, and then that data will get automatically pumped into a server behind. Okay, so that's the kind of thing that we started building. And at that time it was very ambitious project, because we had I'm talking to you about when we didn't have mobile applications or something like that. I think Nokia 6600 had just launched or something like that, Symbian S40 or S60 days. And we couldn't even think that, mobile apps are going to be the future. So we thought building out devices, personal devices, would be the ideal thing to do. So we built these devices which were specific to, a class teacher. So every teacher will have this device, and they walk into a classroom, they automatically can scroll down. It looked more like a calculator, and because those are the hardware product that we can source at that time. And then it scrolls through all the data, like whichever teacher is kind of like assigned to, and then they can take this attendance, like, I don't know if they do it in college even now, that they used to run with a college register and everyone's name used to be there, and then they call out the name and everyone says present sir or absent or whatever. So this used to be that device which used to do all those things. And even it was a very personal device, so if you were correcting a question paper, you can actually record marks right in that. And then when you go to the staff room, the teacher, every teacher has this device, right? So they connect that, and then that data gets synced into the local database there. And then because we found a challenge that every college has to install this in there, they need to have a machine and things like that. At that point of time, we actually did something called cloud. And there was nothing called cloud then. I mean, it was not called as cloud. We looked at Salesforce. I think that time they kind of like had this kind of application service provisioning model where every data was centralized at a single place, and then you keep the data, basically what is called cloud today. Like, you have a storage of your customers with a tenant and things like that. So we built that. We pulled a lease line and we built servers. We did that. It was a very interesting project, but we were way ahead of our time. And so we didn't have enough capital to run this whole thing. So and also there were a few other people in the same in a similar area, but they focused more on, like they used to build it into a CD, their softwares, and that every college has to install it and do that. But at that time, colleges felt it secure to use that than to send their data with us. And I don't know, educational institutions and selling them something was a tough sell at that time. Like, and we had another challenge was like, we were very young people, so people didn't trust us in any form, even though we could think of technologies and with whatever with whatever knowledge we had and the internet at that time, we could build things, but people didn't trust us in many ways, right? So it was very challenging. I mean, today, if you go to a Starbucks or a coffee shop in Bangalore, and every youngster is a CEO, a CTO of a company, and it is very inspiring to look at them. But at that time, it was very difficult because there was no support. I mean, except your parents and a few known people. Everybody else who asks you like, "What the hell are you doing in your life?" They will say, then you say that you're starting a company. It's like, go, don't do all these things. Just study hard and crack your interview at one of those leading companies, and that's what life was all about, right? So we were very, very ahead of the time. So we couldn't sustain, and we had to shut it down. We moved to consulting services at that time. So I worked for some of the Maldives government projects. We got some projects from there. So I was in Maldives, I was working with the government there. We built some softwares for them, and then eventually we couldn't sustain it. Like, the income versus the expenditure was really a massive difference. So we had to cut short everything, um, and then wind up everything, and then I just quit everything from there. So yeah, I mean, I've not shared this story in a long time. I'm pretty sure I'm missing a lot of things, but thanks for reminding me. I mean, I was not even expecting this question to come in at all, when you said you wanted to chat with me about my journey.
Yeah, that's true, because a lot of times when we think of institutions, like, okay, let it be an institution like something like a top notch, something like
Mhm.
IITs or NITs. It's not about that. It's all about that individual who just comes out of that. Sometimes, when you think of this era, I think everybody knows what cloud is, what
Mm.
does the data privacy and all these things. At least more than what people knew during that time when you started off your company. I think probably that's the journey today. Like, there's a massive shift that we are talking about when
Yeah.
people talk about all these things.
Mhm.
So I just wanted to ask you this one question, because, like, what is it all about when we are talking about something which is very close to a .NET ecosystem, which is already a massive movement which has already happened in the industry, but yet we are yet to uncover some things which are improving. Like something like, okay, there's a long-term support for some versions of the .NET, but there is no long-term for some version of the .NET as well, even today. But institutions like AWS has .NET support,
Mhm.
Firebase has .NET support, and a lot of things. So migrating from one version to other is a pretty big challenge, because I can't
Mhm.
ask you related to C sharp. C sharp is still a syntax. C
Mhm.
sharp still does the job of whatever was paved through that. But I just wanted to realize from your side, like, what's the pains and gains of migrating from one version of .NET to the other? Because
Yeah.
it's a rapid shift that goes in one version to the other, and I think probably sprints really change over a course of time. So what is it all
Yeah.
about when we talk
So
about that sort of an application?
Yeah, so here's the thing, like, when we talk about migrations, I mean, the challenge, I don't see a challenge from .NET 5 to .NET 6. I don't see a challenge from .NET 3.1 to .NET 5. The challenge is because a lot of applications probably have legacy in terms of, like, they were .NET framework based applications, right? So you have to understand how .NET is a very old, kind of platform, and it has been evolving since a long time. Like, for example, when I started with .NET, it was in 2003, 2003 sometime, when, if I remember correctly, it was .NET 1.1, I think. There was one version before that was 1.0, right? So it was called .NET Framework, and it was very glued to the Windows ecosystem, and it was a very closed source. So everything into the framework were very dependent on the Windows DLLs that you would use, right? So, industry has shifted. A lot of open source, cross-platform things started to evolve, and over the period of time within the .NET team itself, there has been a lot of change in terms of, like, embracing the open source culture, and to kind of like go ahead and look for open source implementations rather than baking something of our own. Such example is, say, WCF. It was one of the greatest tech in terms of service to service communications and things like that. But that still is not being brought to .NET Core in an official way, or the .NET Core is a cross-platform, the .NET, right? And then now the .NET 6. So um, so so you look at when you look at that, we did not bring the WCF, but instead we embrace gRPC, which is what the world is looking out for in terms of technologies and things. So there has been cultural shift, there has been technology shifts. So these evolutions kind of like took time, but it has always been like, we've been trying to support with every single version when we release it. But yeah, as you rightly said, there are challenges, but that's what something we do with, there are tools like upgrade assistants, which can help you to a large extent to identify if you have some, let's say, .NET framework related projects that you want to move to .NET 6. It will tell you these are areas that you need to improve or you need to change. But then, any magic tool that you want to build can never be 100% correct. It always comes with challenges. So yeah, so that evolution kind of like has its issues, but at the same time, it is also important to understand that, if you are in .NET framework and you don't want to migrate, it's totally fine. You have legacy applications, you don't want to migrate it, you still can run it on .NET framework, because .NET framework is included in your Windows operating system. So as long as Windows is there, there would be .NET framework, as they say. So that way you don't have to. But there are situations where you want to migrate, like for example, embracing cloud infrastructures and modern cloud native technologies and things like that. So that will force you to move, and that's when you look for these high performant, the platforms like .NET 6. So if you're bringing .NET to .NET 6, there would be some challenges, but that challenge, that fixing those things in a staged environment, it's all worth it. And we also say there's something called a strangler pattern, which people use to kind of like modernizing legacy application to more modern applications. So yeah, you can follow some strategies to go and migrate, but yeah, and for example, if you have WCF services and you want to migrate to the most modern one, you don't have to like you have to change a lot of thinking as well, right? So from WCF, you have to think in terms of gRPC, you have to embrace gRPC. But a lot of the .NET code, which is in the shared basis, can actually be shared across as well, into the newer platforms. So yeah, so there will be challenges, but I think it's all for the overall good, I would say. But now it's more stable in terms of our release timelines and things like that. Every year there is a release, and every alternate year is the LTAs, which is a long-term support. So if you are once you bring your application to that kind of cadence, you will be totally fine.
Once Kelsey Hightower really tweeted that .NET is an operating system, and I was like, okay, fine, that's also there. That's fine. That's also an app description to that as well. But when you actually in the event, I think last Samosa Chai event, I think probably you openly told that don't blame an performance of an application because there's an adversarial performance effect which is given out by an ML model, and you told that ML model is just a spike which you just get by the detection of something, and it's based on the training and everything. So when you talked about the testing, I think I was the one who asked that question.
Okay.
Yeah.
Just tell me the
So
question again. I might have forgotten that.
yeah, it was all about how is the performance affected when we are migrating an application with an ML application, like
Okay,
including
got it.
an ML on it.
Mhm.
So how is it going to affect? So you just gave me that example. That was a really apt description for that question, because I'd say like we always complain about this is not good, that is not good, but the insight's always about the data. Like it's all about the data. But .NET has really changed the way in which the development had happened, because I was in Flutter guy for a very long time, and I know how native applications are. Like it's like cross-platform. It's always available on iOS, Android, and what do you want more? It's also in web as well. But .NET is also flexible as that. But testing it becomes an even more bigger frustration when we just go for deployment at scales and so on. So what is it all about when we are thinking of cross-platform testing using the .NET application, which is already built? Because we still blame some false attribute, something like, hey, we just did ML.NET and it's not working proper. But we really don't understand that it's the ML, which is based on the probability of it. It's not about how our app is performing. So what is it all about when we think of such kind of an testing environment that we want to build for entire scalable application today?
Yeah, I think there are many things you mentioned here. One is the ML related and the general testing and performance of the applications and things like that. So I'll go one by one. I mean, when it comes to ML, when it comes to machine learning, I think one thing is there is a slight change of attitude towards ML development, which is you don't build a perfect ML algorithm overnight. You take the data, you'll make the algorithms learn it, and then it would be, to some extent it will be done correct, but then you further add more and more data to improve it, right? You will be, and there are a lot of other processes that I'm missing or telling, like cleansing the data and things, like making sure the data that you're using for, a training and ML, it needs to be right and things like that. And there is also, people say that, take the 70% available data, train them, and take the 30%, test them, right? So ML is always an evolution. So, for example, um, I think it's the spam filters that you use in your emails, right? They have improved so much over the period of time. I mean, when you had like, if you had, like me, had Hotmails or the Yahoos of those days, the kind of spam we used to get then was huge. Now it's overall, even though there's a spam, it's already filtered out for you. So if you just have to go in and see if it was the right filtration. So it took over the years, right? So petabytes of data to be taught and learned and things like that. So that's always going to be there, and it's a continuous process. So we're going to get better and better and better and better. So with the kind of data that we'll accumulate over the period of time. So that's with ML. Now, you said about testing, about .NET and having multiple areas of testing and things like that. Even though we speak about .NET being available on all the platforms and things like that, it is not always that one single person is actually working on all of them, right? So everyone will have their niche. So for example, if I'm a mobile developer, I may be I'm a C# developer, but now I want to work on mobile apps and things like that. That's when you have a mobile platform with your skill sets to build it, right? So then you will be focused, because each and every area is so in depth. It's very hard to kind of like learn everything. You can become jack of all but master of none. I know people talk about being full stack engineers and things like that. While that is true, the ability is good, but at the same time, you also have to have your core at some point, right? So that's where you would become an expert and you go deep dive into it. So think of .NET as a when we say .NET is for, it can be used for many things. We're talking about larger companies where they have large set of people with this .NET skill set. Now they can help them to navigate through any verticals they want. If they want a mobile developers, they want to work on mobile, they want to work on the backend. Those things are different, right? And so psychology is also different here, right? The way you build mobile applications and test is very different from the way you will deploy and test your backend applications, right? Gone are those days when we used to deploy our application, we knew we could literally touch the server and say, this is where my code is running on. Today, that's not even possible, right? You don't know where your code is running. You don't know the hardware where it is running. So now the way you look at things have also changed drastically. So everything, well, the way I look at it is like, everything has its way of looking at it. Like the way you build web application is very different from the way you build mobile application. But having that ability to really go and do the particular area of interest that I want, and that's the key for me. I could go and build a mobile application. I could build cloud native stuff. You I think before we started the call, you asked me about how I moved from Xamarin to the microservices and things like that. The only thing that changed for me, the language, skill sets, everything is same. The only thing that changed is I needed to understand how the cloud works. I need to understand, how do we save money when you write codes, right? So all these things are the things that you need to upskill, and this is going to be constant from now, right? There would be, well, I can tell you from my last 16 years of experience, every month I had to be on my toes with the tech. It's never easy to say that, like, okay, I've learned this thing, so I'll be with it, right? It's always evolving. There's always a new language, there's always a new technology, there's always something new. As you said, AI, ML, you need statistics, the knowledge in statistics and mathematics more than ever when you have to build those things, right? So that aspect is key. And if you are a developer, I think that open mind is a very important thing, to kind of like, go. There is never going to be a stagnant space. It's going to be always moving, the water is always going to be flowing. You have to be at the edge of it, I would say. So yeah, that's what I would
That's
say.
true.
Mhm.
Yeah, because we all have that one way to complain about anything. Okay, TensorFlow was not that good, so we will go to the PyTorch and we'll start working there. That's how we complain every single day about like frameworks, about this, about that. But
Mhm.
what .NET brought to the world of development of mobile, I think probably when I still remember the state of the art phone that I saw was Galaxy Y. It was
Mhm.
not a big deal back then, but to me, when I saw Galaxy Y, which was a touchscreen phone, apps were running amazing there. And that was so cool to me. But today, when I see an application, it's so light versions are also available. And also, it's much more functional. Like, it's like, okay, you have this function here, next what? Like, they just keep updating.
Mhm.
And the way I was updating was also different, right? I still remember, probably an year after installing an app, I still remember, that asked me to update your phone. But
Mhm.
now it's like every week or every day, probably sometimes, somebody go nuts about like, hey, there's an update here. So just update it. There's so many notifications today.
Mhm.
The way which we are delivering software is becoming more agile over the course of time.
Right.
But what I see about the mobile application platform is that there is a different mechanism to it altogether. But what's the culture that is changing when we talk about the mobile applications than the regular applications that we talk on as in software? Because there's a lot of way in which we are perceiving tech is different. Like
Mhm.
back then there was a website which used to do all the work, but today it's an application which does a lot of work than a website.
Mhm.
So how is it all about when we are building such a kind of a tech, but also catering to the needs of the people?
Mhm.
How is .NET an ecosystem going to help it for the future world that is moving more towards the mobile and edge-based application? Because
Mhm.
it's all tight memory, tight battery, and things like that. So how is it going in the .NET ecosystem for all these kind of applications for tomorrow's world?
Yeah. So see, as you rightly said, I think there's one thing that we keep telling ourselves in this industry is that the problems that we solve in the tech world are never tech problems, are people problems, right? We build solutions for people. We build solutions for humans to succeed. We try to push the human race forward, right, in all the things that we build. So it's always so as you mentioned about mobile applications. Yeah, I know there are capabilities. We know that notifications and things like that are capabilities. As a developer, you could just do that. But I think it's also the time to decide, like what kind of application that you want to build. And if you're building something like if you're not building a chat application, for example, you don't need to be notifying users all the time when, right? So taking those kind of decisions for your apps is very crucial as well. um, so so deciding that when to notify and things, and also respecting like do not disturb modes and things like that. So those things are always there. And I think you talked about the edge, and I think your specific questions were where .NET is kind of like focused. The answer to that is very simple. I mean, .NET um, as a tech, we are focused on where you want to be, right? Where do you want to write applications? So we want to help .NET developers write applications there with the same technologies and performances and the learnings that we have built over the years now, right? So you want to build for Linux. Earlier, those were not possible. Like building applications for Linux using .NET was not possible. Today it is possible. And if you were to run on IoT devices, it's possible, right? You want to run on ARM64 devices, you want to run on the latest MacBook M1. This is all doable now. It's all possible. So tech is the least of the problems, I would say. It's all about, let's say, hey, Vishwas, .NET, can you help these cancer patients with some unique thing that will help them motivate their lives? You would say yes, because with the knowledge that you have, you should be able to do that with whatever is provided to you there, right? So that's the way to think in all these things, I would say. And as a developer, to all the youngsters out there, that's what I would say. I mean, tech problems are the least problems, honestly. The bigger challenge is always solving things for humans. Like, how do we help people? Like, for example, even though I can write mobile applications and I can do many things in mobile. My all my phones are like completely on do not disturb mode. Like, I don't have notifications of WhatsApps or any of the chat applications. And I know emergencies work on people can call me. So except my email and phone and the regular SMS, there is no other notification that's enabled on my phone. Because at some point you have to understand that okay, these distractions are not going to help you in various ways. So it's important to step up the game and say, okay, what do you want to be notified about, rather than letting the app, the most performant phone, to decide how I should lead my life, right? So so that shift, I'm pretty sure it will come to many customers. So as a developers, we need to understand that we should help developers, sorry, we should help our customers or users in leading a healthy life, or helping them succeed in what they're doing, rather than thinking about what a particular framework is not doing, or what tech, what language has brought in. I mean, these are all things which are, you can easily shift, right? Today, if one tech doesn't work, you can always move to another tech. That's not a big deal, right? Compared to the problems that we face, elsewhere. Like, for example, in the real media, a real world, the kind of problems that we face is very, very different. So, for example, even if you look at now the social media companies, they're working hard to help fight the fake newses and things like that, right? So these are real problems that people want to work and fix. So, which kind of helps, which is kind of like a break, like a deal or no deal kind of a situation for people, right? So yeah, so I that's the way I look at it. I don't know, I mean, if your listeners have a different view or opinion about it, yeah, feel free to, I'm happy to read the comments and learn about it.
Yeah, GitHub Action is the key there. Like, it's something like, okay, you had CI/CD, you had specific tools to do CI and CD, but GitHub Action is a state of the art tool today. Like, it's something like you can do CI here, CD here. You have artifacts also there. Like, you can do everything, but you need to know where your application is going to fit in. Like, is it going to be in something open source or something like mission critical? And I think probably .NET has solved all these issues. Like how GitHub Action came to the world like a superhero. Like, it's like .NET has everything. It has SDKs. Like, back then when I still remember, I think 3-4 years, like when I started engineering, x86, x64 was something which was common. Like any installation media, you go there, x86, x64 was a common thing. But today when I see ARM 64, ARM 32, this, that, I'm like, man, this is crazy amount of deployments that are happening at the scale. Like, every device has a specification. But I was very struck when Equifax got their story out. Like, it was an Apache struts vulnerability and things like that. So it's all that community which got, like, Apache had its own vulnerability, CV was raised all over again. But I just want to realize, like, there's a way in which we are always catering to the needs of the people. Like, there's a new device here, then we are ready to build a software for that. That's how software is more agile towards, like, open source is even more agile than that. But when we think of something like the DevSecOps aspect, like something like CVE has been raised already, and there is a community of developers who are working towards it. Like, how is .NET being that agile? Because .NET is loved by more than 1.5 million developers. Like, even many companies have been, like, they have a ritual in their company. Like, anybody who knows .NET gets hired here, kind of a stuff. So how is it all about when we talk about .NET community when it comes to the security aspect? Because not we know that there is a lot of frameworks which are already built on .NET, but like, how is it all about when we talk about the security and the community which is supporting it, keeping it more up and running over a course of time?
Yeah, so I think the question is more related to the security aspect, right? So see, there's obviously like a lot of amazing engineers work in our team to make sure that the platform and the SDKs that you're using are secure, and it has been tested to make sure that there's no kind of loops and things like that for vulnerabilities and things like that. But having said that, so .NET is a very or the platform is very low level when you compare to the application that you're going to build from there on, right? So the security aspect is up to the developer, who would eventually start using and building applications. For example, you mentioned about GitHub. GitHub has this nice SecOps built in, which kind of analyzes and tells you if you have by mistake probably injected a piece of code that is vulnerable, right? Or probably you have keyed in some secure string which shouldn't be checked into or committed into the code, right? So there are those tools are there so that your final delivery does not are as secure as the platform itself, like once you build the applications on top of it. So I think those are the aspects that comes into, even as you mentioned, it comes to the DevOps cycle, where they call it as DevSecOps now, and which is where you kind of like strengthen those build servers and things like that, and analyze code analyzers to know that the developer is not, even by mistake, is not committing things into the source code to avoid all those vulnerabilities and things like that. And we have also, if you, I don't know if you know about Microsoft generally, since we run on Azure and things like that, there is a lot of standards and things that the entire infrastructure goes through, the hardware and things like that, to make things secure. And all over and above that, there are white hats or the hackers who actually hack the systems to find out vulnerability from their side, to make sure, so there are teams which will actually constantly, their job is to wake up and then hack a system to know that there's nothing changing there. So I think, again, when it comes to security, also just like we spoke about ML, it's a constant practice. We can never say, you can never call up and say like, oh yeah, I have a very secure thing. The moment you say that, the next day you will get hacked, because it's always like that, right? You always find a problem and then you find this fix for it, right? Something like any kind of security hacks are also like that. Like once an incident happens, then you try to figure what because they're always, the way to look at it is they're always one step ahead. So we need to we can only try to reach and make sure that everything is hardened and secured. So yeah, that attitude, saying when I'm going to build and commit something, I want to make sure that everything is secured with the best of the knowledge at that time, right? Or at the time of committing the code. So yeah, that's a practice. And I wouldn't say, yeah, you asked me about .NET as an ecosystem and community and things like that. So even though those are all there, I think the larger thing is to make sure that the developers who are using the tools also follow those kind of practices and things like that. The few things, like for example, NuGet packages, right? The libraries that you use, those things also go through extensive check to make sure, because those libraries, you can actually use it in your code, somebody else's code. So those things need to be checked for vulnerabilities as well, right? Because you can put in your extension there and it can have some malicious code. So those things are also constantly checked. So that aspect is always there. Like having that, what do you say? Having that entire thought process of making sure we are writing secure code, and then constantly evolving it.
Yeah, that's true, because cloud native really changed the way in which we are perceiving the cloud today. Because it's
Mm-hmm.
like, okay, Kubernetes was there. What next? There are even more CNCF projects coming. They are graduating. They are being actually nurtured from the CNCF, and I hope that someday we might stop the development, but I don't think so. We are just going to stop it at any given point. So, what is it
If
all
we had to
about when
stop, we
we?
would have stopped it during radios and televisions. So
Yeah, that's true. We wouldn't have it stopped. Yeah. So, like my last question is all about like how are we building the resilience on all these kind of architecture that we are developing? Because .NET is something like .NET is there in Pulumi. .NET has Pulumi is actually an infrastructure as a code. So it's basically something like, okay, you have infrastructure, so you can write the infrastructure in the native application as well. So it's like it's there in the code as well. So building resilience today is something which .NET actually showed to the world. It's something like .NET has amazing set of frameworks, amazing set of support already which is built, and of course documentation is awesome. So it's always there. So how is it all about when we are building such a resilient system for the tomorrow's world? Because we are now coming up with data meshes. We are now coming up with new technology for the data world itself. So it's all about that way in which we are seeing the tech is also changing. So what is it all about when we are trying to build such kind of a resilience? Because of course there is microservices for all of this, serverless for all of this. But what is it all about when we are thinking at scale and building resilience at scale for all the applications that we are building for the tomorrow's world?
Yeah, so here's the thing. Yeah, since you brought up resilience and cloud native and aspects, and you also mentioned about CNCF having newer and newer in projects, and then it's so everything comes out of the need. Like necessity is the mother of invention. So if you look at all the projects, it caters to a specific problem and it solves that problem, right? For example, when it comes to Kubernetes, even though it's very challenging if for the first timers to understand, the learning curve was like kind of huge. But if you really look at, we're talking about where you don't touch infrastructure anymore and you program these infrastructures, right? And if you're deploying applications, you deploy based on specific configuration files and things like that, and no more um, no more about like logging to an FTP, pushing in the code there. I don't know if you've done these things. I've done these things in the past where you deploy to a server and then it just doesn't work, and then you FTP into that machine and you figure out, okay, there's a configuration change that didn't go well. You modify this configuration change, and those changes don't come back to the source code ever, and it is always forgotten and things like that. So that those kind of things have happened. So now when you talk about cloud, we're talking about this huge, massive infrastructure where you cannot do this anymore, right? So that's when these technologies are kind of making it easier. Our lives are going to be easier, and at the same time, you can think of it like this, right? You take a largest e-commerce application, there will be like 50,000 people working on it, right? 15, 20,000 people on development, maybe difference on the different geolocations and things like that. Imagine if everyone have to wait for one person to fix the code to just deploy it. It would not work, and that's why those split happened. And when that split happened, they all have to work together. So you need some sort of how some sort of patterns to help. How are these things going to work? Are we going to do a service to service communication synchronously or an asynchronous? Do we have to bring in messaging queues that gives you guarantees, right? So this is how the necessity comes and that evolves, right? And you talked about resiliency. See, one of the things about resiliency is like when you connect with other services, there could be they're all error prone in the cloud, especially with Kubernetes. You don't know when the pods are getting deleted and getting the new one is getting created. You don't know the path is always accessible. There may be 404s in between. So you build the application to be resilient. Now the thought is like, okay, let's have a code and write some logic to it. Like for example, I can write a retry logic. I connect to one service B. It's not a so I will write a retry logic to connect again. So because you keep hitting it a number of times, it could be DDO, denial of service attack, right? So it can happen, denial of service can happen. So what you do is you do an exponential backup, which is like you wait for some more time, exponentially wait and retry, right? And then there is circuit breaker and things like that. And people looked at it, it's like, oh, wait a minute, why do we have to do this in every single piece of code? Like every single service that you build, everywhere this code has to be there. So let's move this thing out of it, and we can bring in something like a sidecar, like service mesh, right? Where that whole thing will be handled separately, and you write on the business problem that you want to focus on, right? So as I mentioned, I mean, I can't speak for specific cloud native technologies, but I honestly feel that there are obviously the technologies exist and they exist for a reason, but it's very important to decide, does it work for you? Do you need it, right? And the other thing that we generally say is like, is it backed by good people? Is it backed by open source community? Is it a very very healthy environment to be in, to use those products and things like that, right? So those are the things that you need to look at it and then start investing, rather than just picking up tech and then making it work, right? So as I mentioned, see .NET, within .NET you can write resiliencies, retries, and circuit breakers and things. But when it comes to cloud, I wouldn't do that because I would want the sidecar to do all those things, right? And for example, another thing, like if you want to do service to service communication, you want to connect to a messaging queue and other things. If there is a sidecar that can do that, like for example, Dapper, I would choose that because I, as a developer, I want to focus on people problems. I don't want to waste time on my infrastructure problems. That's when I will use those toolings to help me succeed, right? So that thing is very important to identify and then and then build things on top of that. So did I answer your question?
Yeah, that's
Okay.
true because I think there's an immense amount of application which is already built, but I think to one extent I think developer advocacy and DevRel is actually making that impactful move
Mhm.
because not every because it's all about like bridging that gap because I know some language, I know some frameworks. It's all about like gone off those days where top to bottom you used to write stack in only one language. Like you can write a stack in a React, get an API, then make sure that you get another stack in a Go, other stack in a Java, like whatnot. It's all
Yeah.
about that, it's all about the bridging gaps between the developers. It's all about like the developer advocacy coming in and just educating
So
developers over a course of time.
yeah, as I mentioned to you, it's like even the philosophy of our teams and things like that, like you come with the .NET experience. We want to give you the best available platforms and skills. I mean the platforms available for you to build on top of it using the skill sets, and we want to give you the best tooling support and things like that. But like for example, if you want to work on Python, you want to work on Node.js, it doesn't matter. Like if that is going to solve your problem, you should embrace that and use it, right? So that's it's always been like that line. And now with this microservices world, the more we embrace open technologies, it just gets better for the ecosystem, because now, as I said, resiliency code written in .NET will not work in Node.js. So you have to write Node.js resiliency code separately. Now with a sidecar, that whole problem is solved because you're no more writings about any of those things, because that is actually the cross-cutting concerns are moved into another layer, which is handled by another library for you. So you're only dependent on the configuration. So it's always like that. Like for example, Azure Functions, like serverless platforms, right? You really don't want to spend time with infrastructure. You want to solve the problem. You want to solve a business problem. You just need a something service running behind. You just use that, right? Like for example, we announced something called as Azure Container Apps. You don't want to learn Kubernetes, but you still want to deploy to Kubernetes. You still have a massive application that works with each other. You don't want to learn Kubernetes. Totally fine. As long as your application has a Docker file to it, it can just deploy it and it just works, right? It can have a Node.js, or it can have a Python, it can have anything. Like they all can work together. So we're looking at this great harmony in the cloud world, where it doesn't matter what tech you bring in, as long as that tech solves your problem. That's what is more important.
Yeah, that's true. That's true. I think thank you so much for such great insights. I think we didn't have a pre-podcast call, but yet we were able to manage with good amount of questions because yeah, there's ample amount of content which is already available on internet, folks. So you just have to just reach out to that and just get the thing sorted. I think thank you so much, sir, for giving such a great podcast and such great insights on my podcast. Of course, I know that you have not been in ML space for a very long time, but thank you for sharing that insight as well.
Yeah, I really appreciate it, and I appreciate your time and everyone who's listening to this podcast and who's finding it useful. And if you've come this far, then I'm pretty sure you've been finding it useful. So thank you so much, and thank you so much, Vishwas. And I wish you the very best in whatever you decide to do. Yeah, good luck, and feel free to reach out anytime.
Thank you so much, sir.